I'm just gonna assume we are, and then if anything goes wrong, we'll just have to refilm this. But anyways, we can get started again. Hi, I'm Emily. I'm the developer advocate for Linea. Today we have Marcin from RedStone, Hilmar from Gelato, who's just, I guess Gelato's just, this is like the fourth time?
The 100th time, it feels like, yeah.
Too many times. But anyways, regardless, this is super exciting. I think we've been doing workshops kind of just like one off with I guess a single project, but like RedStone, Marcin, you kind of I guess what do you call it? Uh introduce the idea of kind of doing it together, and I think that's really exciting. I don't know if you guys know this typical format, but basically this time I think I don't have to do anything other than let you guys take it away. So my one job today, I guess, is to say, please introduce yourselves.
Wow, can I have your job, Emily? I want your job.
Yeah.
It's a great one. It's a great one. But yeah, I can quickly take it away. Hi, my name is Hilma. For the third or fourth time on a call with Emily here, so by now you should know me, hopefully. I'm one of the co-founders of Gelato. Gelato's Web3 is decentralized backend. We helped developers to augment their smart contracts by making them gasless, automated, off-chain aware. And yeah, today we have a really cool, exciting use case which combines RedStone oracles, and we will show you how to push them on Linea using Gelato. So super excited about this.
Yeah, hey everyone, my name is Marcin. I'm co-founder of RedStone Oracles, and I feel like this guy that goes for the first time to a new group of friends that know each other very well and is for the very first time. So I need to do good first impression. As Emily mentioned, initially it was just Gelato to present Web3 functions, but as we are quite close with the team, I was like, hey, we like Linea. Why not to join forces and present something even more interesting together? I mean, always two heads are not the one, right? So as for RedStone, we build a new generation of oracles where we redefine the flow of data. Instead of simply pushing it on chain and consuming a lot of gas, we create like an abstraction layer off chain where we aggregate the signed data packages and we deliver it on chain or directly to dApps in many forms. And to make some of these forms even more developer friendly and more efficient, Gelato comes in handy with their Web3 functions, which we are going to present today. So I suppose I pass it back to Hilmar to do his magic about gelato and ice creams.
Okay, Hilmar, are you sharing slides or?
Yeah, I will share my screen. Let me just try this thing, and you can let me know when you are seeing it.
It looks good. So I guess Marcin and I will just sit here and look pretty, and then
Yeah, just relax and let me take it away from here. I will try to be as quickly as possible through these slides so that we can get into the developer stuff, the code in no time. So yeah, the title of today's quick presentation that Marcin and I will hold together is how to bridge off-chain data to your dApp using Web3 functions and RedStone oracles. And so super excited to talk about this. And this is kind of like an agenda. We'll quickly walk through how kind of like the current backend architecture of Web3 applications look today, and then actually how to build decentralized and serverless push-based oracles using Gelato, Web3 functions, and RedStone oracles. And then we will have a demo of actually going into the code and having a look of how this looks in production. And I will actually basically start this sort of automatic push-based Oracle live here today, so you can see how it works. Awesome. So backend architecture of Web3 applications today. I think a lot of you that might be starting out in your Web3 journey, what you kind of like think about is, hey, I have my sort of front end, my React application that I built, and I have my fancy smart contracts that I put way too much time in. And hopefully you use the right compiler version if you if you use Viper, for example, right? Or better, just use Solidity. And yeah, then you think you're done, right? This is it. This is just my application. But obviously, we all know that this is not the case, right? There's this whole sort of backend infrastructure needed in order for you to actually build user-friendly and kind of like applications that people actually want to interact with, right? And there are all these kind of things. You need databases, you need to kind of like read and index data from the chain to make it accessible in your eyes. You need to sort of run jobs to push, for example, and relay transactions on chain to connect some sort of off-chain world to the on-chain world. You need to be able to fetch off-chain data, where, for example, RedStone comes in and give it integrity, so your smart contracts know that certain data is actually like truthful. If you want to do that in an automated way, you need to store private keys in the cloud. You need notification services. You need all this kind of stuff out of the box. Like, you need to build all the stuff and run it yourself in order to actually make your whole application work, which sounds like a lot, right? And problems with that, of course, it's very tough, right? You need basically people doing that, managing that, and actually scaling that is very difficult. Alone managing the connection to the blockchain with RPCs can be a pain, especially on like newer blockchains where these RPCs might be not as stable. If you use external providers, like paying multiple of them in like different tokens and currencies, or even off-chain, is a hassle, right? Then if you actually want to deploy multiple chains, you need to replicate these servers across multiple chains and deal with every single quirk, every single blockchain's quirks. And yeah, the sort of sensitivity of storing private keys in the cloud is always like scary. And obviously, if you do all of that yourself or use a centralized provider, then you become a central point of failure within your system. And yeah, why are we building these decentralized applications in the first place, guys, right? So this is where we want to come in as Gelato. We come to the rescue, and we want to help you by providing you with a lot of this backend infrastructure in a decentralized way. And today I want to talk about Web3 Functions, which is the service that me and Marcin will showcase for you today. And how you can think about Web3 Functions is basically sort of how I think of it is it's kind of like a way to transport data on chain. And it's basically enabling your smart contracts to spin up servers in the real world and let these servers kind of like send transaction to itself in order to, I don't know, get, for example, price data from, let's say, Binance or Coinbase or other centralized exchanges, right? Or you can, as a smart contract, you can let a server send an email to, I don't know, your users if you want to be, if you want to do that, right? So there are all these kind of things where Web3 functions come in, and they're kind of like decentralized cloud functions that can be spawned by transactions on chain, which is quite interesting. And so how it works is, or what they do is they allow your smart contracts to communicate to the off-chain world, to off-chain computation, basically. And these Web3 functions, they run this off-chain computation on your behalf. You can run it, let's say, every minute. So you can have this cron job that every minute runs a certain like logic, or you can make it event-driven, that every time there's an event on chain, you want Gelato to run a certain sort of function off-chain and then potentially send transactions to over 14 different blockchains. And the cool thing about this, you can pay with everything like in stable coins, in USDC, for example. So you don't need to hold any sort of volatile token that might depreciate in value if there's a Viper compiler bug. And how it works concretely is that you write a JavaScript file or a TypeScript file. I will show it to you in a moment. And we walk through an example. But what you do is, rather than sort of sending it to like a centralized server or a centralized database by us, you actually deploy this function to IPFS. So you just push it to IPFS. Now there is a ID that points to the location where this function sits. And then you go to Gelato nodes and you tell them when they should be running that logic. And you can say every minute or every time there's an event on chain, please run it. And then Gelato nodes will run it. They will call any sort of APIs that you would like, for example, the RedStone APIs, and then they will deliver that data on chain based on where you want to have it, your target contract on Linear, for example, and then you have that data available on your chain, which is great, right? And there are a bunch of really cool killer features that we have enabled. So you have full TypeScript support. It's very easy to write. You don't have to write like WASM or Rust or something, right? Good old TypeScript. Then you have a multi-chain RPC provider. So you have one RPC provider, which lets you read from over 12 different chains in one single provider, which is super cool. It's kind of like this wrapper. You can set environment variable secrets. You can make these functions public or private. We can have another session around how you can actually make them private. There's some in-function state management, so you can have storage, you can store certain things in one run, and then let's say a minute later in the next run, you can access this data. You could pay for it super flexibly, like the more you consume, the more you have to pay. And so if you're just starting out, it's basically for free. It scales very nicely. And the cool thing is you can actually have like smart contracts spawn these things. And these smart contracts could not be owned by anyone. You can just have a smart contract that just like lets Gelato spin up these cloud functions and like return certain things to itself without having this smart contract be controlled by any human in the world, right? The smart contract just needs to pay somehow, right? So if it has money, the smart contract, it can do something, which is cool. And there are a bunch of cool use cases. We will walk through one today, which is basically pushing RedStone price oracles on chain. And this could be useful for lending markets, perpetual protocols, or any sort of other DeFi applications, right? But you can do other crazy stuff. You can sort of have dynamic NFTs that change based on anything like happening in the real world, right? You can push price data on chain, for example, from like aggregators like 1inch that are very custom to specific users. You can resolve real world events from sports sites that have APIs, right? You can do all these kinds of cool things. And there's one small bonus slide before we jump into, and I will give it away to Marcin to talk more about how RedStone is awesome. It's our one balance sort of payment system. So we built this payment system that is super cool, which is basically you can put USDC, let's say, on any chain like a Linear or Polygon, for example, right? And with that balance, you can pay for all the transactions and all the computation across all chains. So you just have a single balance on a single chain. Let's call it your home chain, right? And from there, you can pay for transactions on other chains. So you don't have to sort of interact yourself as a developer with multiple blockchains. And yeah, I think I will give it away to you now, Marcin.
Actually, I'm going to stop real quick and interrupt, steal the thunder. We do have a question, specifically, I think, talking about when you mentioned Gelato nodes running on IPFS. I mentioned IPFS has huge disadvantages. How does editing, updating, deleting your data sets work?
That's a very good question. So what happens if you basically deploy your Web3 function to IPFS, right? So you deploy your Web3 function to IPFS, the content gets hashed and you get a unique ID that points to this particular content, right? So if you want to update that particular piece of code that Gelato nodes should run on your behalf, you basically have to, let's say you do a change in the smart contract, and we can do it in a moment, actually, in my example later on. So let's say you change a line. What it basically means is then you have to redeploy this function to IPFS, which is completely free. It's just like one command line that you put in your terminal, right? And then you basically have to go to Gelato and create a new task to update that logic. So at the end of the day, the only sort of cost that you have right now is that you have to send an on-chain transaction, let's say on Linear, that is fairly cheap, I guess, to then have this update run. And the old task you just cancel. So this is the way how you can currently update your logic that Gelato should run by you. Yeah.
Okay, cool. And then question for my own understanding. So I guess one of the primary use cases, or the big piece about Web3 functions, is the off-chain data piece, as compared to before we had worked with Gelato Automate, which is only smart contract interactions. How do they relate?
Yeah. So how does automated Web3 functions relate? So Web3 functions is basically much more sort of general off-chain computation that you can access. Think about it, like I kind of think about it as next generation cloud functions. So it's basically accessing cloud functions in a decentralized way with crypto and enabling your smart contracts to spin them up themselves, right? Without having to go to AWS and creating like an account and putting like a bank card in there. And you can do a lot of things with it. And like the easiest thing, of course, is to say, okay, I want to just push like on-chain data on, and like don't do anything too fancy. But you can go much crazier, right? You can run like huge algorithms that dictate how you want to do market making on Uniswap V3, for example, right? You can basically everything that right now runs in sort of centralized backend servers somewhere for protocols, and like also liquidation bots, for example, right? All of that can be done in a permissionless way, where the smart contracts are actually the owners of that particular off-chain computation with Gelato Web3 functions. And so, the sort of design space is fairly large here.
Okay, cool. I'm gonna kick you off now because we don't want to hear your voice anymore. Marcin, sorry for
No.
interrupting. Please bring your slides up. Yes, maybe.
Yes, let me try to share my window. All right, can you see my screen?
Yes.
Excellent. So thanks a lot, Hilmar, for giving a real quick overview of Web3 functions. To my understanding, to recap it in a one sentence, it's like a full stack decentralized engine for automation. So if you don't want to have the overhead of manual tasks and you see something is very repetitive, you can basically delegate it to Gelato so that it automates various actions, whether it's on chain or off chain. And when we are talking about the data, so for example, delivering data on chain or doing any actions that is related to a data feed, like a price feed of an asset, then you should have a source from which you pull that data. Naturally, you can go, for example, to a price aggregator such as CoinMarketCap or CoinGecko. However, it's not so easy because sometimes these services have downtimes or can report not that accurate data. Therefore, an oracle can become like a very important piece of that flow. And my understanding is that right now oracles are the backbone of the whole DeFi ecosystem as we know it right now. And as Linea grows and progresses, we are going to see more and more DeFi applications on the chain. So let me first recap what an oracle is. So oracles deliver various types of data to smart contracts, for example, on Linea, or directly to dApps deployed on Linea. So you have various sources of data, off-chain, on-chain data feeds. Then you have an oracle that aggregates and cleans that data. And then you have various ecosystems towards which the data can be delivered. In the current Oracle model, as Chainlink introduced and kind of made a mainstream for the use cases in 2020 and 21 during the DeFi summer, is that node operators push data about specific price feeds to ecosystems. So for example, if you have a pair that trades, for example, BTC to USD pair, nodes are going to push the same price feed to that many ecosystems as Chainlink supports, which is a really nice and simple logic, but it generates a lot of gas cost because when you push data on chain upon an interval or a threshold, a deviation threshold, every time it's updated, it has to consume some of the gas cost, and then someone has to pay for that. What are the problems of such a design? One, it's non-scalable. As I said, on every new chain, you have to redeploy that infrastructure and bear the cost of that. So for example, Linea, to the best of my knowledge, but you can correct me, Chainlink right now is not available. And it offers limited fees because you have to be very cautious when it comes to tokens or price feeds that you support. Second drawback that is related to cost is the update interval, because every push on chain requires the cost of gas. Right now, the average update can be anything between 15 minutes to even a day, depending on the asset that is supported. And as I already mentioned, that flow lacks cross-chain interoperability by design. So with RedStone, we thought, okay, so how we can redesign oracles and rethink it. What we created is an abstraction or like an off-chain layer towards which signed data packages are sent. And now bear with me how we make it. So we created RedStone nodes that are not blockchain nodes, rather like regular services that anyone can spin up and run, which fetch data from either off-chain sources like centralized exchanges or aggregators, as well as on-chain sources, so DEXs via RPCs. Such feeds are aggregated on a data provider node level, and then each data provider, whether it's RedStone, Kaiko, ForestV, or any other data provider that is willing to run the service, sign a data package and then sends it to our off-chain component, which is a data distribution layer. And basically, it's a redundancy layer that keeps that data for a short period of time for anyone to pick up. I'm not going to go into details how it's constructed. You can read everything in our documentation, but basically it's a set of redundancy services that make sure the data is available, it's decentralized, and anyone can join this data distribution layer and spin up their own gateway. And then we have 3 dedicated models upon which the end user, so a Dapp or a protocol, can consume the data. How it looks in MetaMask, for example, when you have the signed data package attached to cold data of a transaction, if you go to your MetaMask and to the hex section, you are going to see like the signed data package is literally like attached to a transaction of a user in one of our models. You can browse through all the data that is available with RedStone at app.redstone.finance. For example, for Ethereum, we have 40 sources. Actually, right now, I think we have even less sources than 40 because recently we had to do some cleaning because we actively monitor which sources are valid, which are new sources that came into existence, which are deprecated, right? Because as you've seen with the curve example, nothing is set in stone. Like you have to constantly monitor and manage the situation on the market. Unfortunately, I think right now Ethereum trades at a bit less than 2,900, but this screen is from a while ago. Thanks to that flow, we are capable of delivering other price feeds than just blue chip tokens like Bitcoin and Ethereum. For example, we can have yield-bearing tokens like GLP or LP tokens. We can have stake tokens like staked Ether, wrapped staked ETH, staked AVAX, or even very customized integers like individual refugees from Ukraine recorded across Europe, which was a feed created by one of the developer for a hackathon Kiev Tech Summit. So it just shows that the customizability opens up with such a flow. So when it comes to the data feed, what do you get? To recap, because I would say in the context of Gelato, this is the most important part of ours, is that we take care of the accuracy and reliability of the data feed. And we pay a lot of attention to that because we take it from various sources, as I said, off-chain and on-chain, and we constantly monitor and try to clean the data as much as it's possible. Recapping the benefits of such design, it's scalable because if you keep data off-chain, you can deliver it to many ecosystems upon various conditions. We cover right now over 1,000 of assets. Actually, it's 1,200 as far as I remember, and we keep on adding new ones. The average refresh interval that we offer is 10 seconds, and right now we experiment with going sub-second. And such design is cross-chain by design. So we started supporting Lina from early days. I think it was like literally a day or two after the mainnet has been announced. So we are very happy to be in the ecosystem and support the builders over here. Okay, and now going to the Gelato part. So I already stated that we have pretty good data over there, but somehow we have to deliver it on-chain or directly to the Dapp or Lina. One model that we created and people can use is called RedStone Core model, which is an on-demand model, where if a Dapp on Lina integrates RedStone, then after every transaction that the user sends over a Dapp, to this transaction call data, RedStone signed data package is attached and then sent on to Lina, which is really gentle and nice idea, but for some protocols, it doesn't work because they require data on-chain. And that's a moment when Hilmar and Gelato come all in white to the room and offer their Web3 functions, which can work as a relayer and basically fetch data from our off-chain component and deliver it on-chain again, either in the model of Chainlink, so with a set interval and deviation threshold, or even more complicated logic depending on the on-chain events. And this shows the power of our X model as well, which prevents from front running, where the data is updated after a user of a protocol requests a specific order on chain. So there is an order on chain, the price is delivered, and only after that the order is settled. And with that, Gelato comes very handy. This is a bit more detailed flow of the X model. The last one I explained on GMX example that can at one point run on Lina. I hope so, fingers crossed. Where, again, to recap, user requests, for example, opening a short position. This request is recorded in block number N. Then from our data delivery layer, anyone can fetch the data, deliver to the Dapp itself, and then the execution happens on the very next block. And here, this everyone is literally Gelato Web3 function infrastructure. So to show you a real case example, we have a demo of RedStone and Gelato Web3 functions running on Girly testnet for Angle, where this month, as far as I understand, were 200 updates already. The data feed itself is C3M, which is an ETF that relates to bonds in Europe, which is a fairly custom data feed that is not available with any other Oracle provider. And there is 100% success for all of the updates, which is a fairly good result, right? I'm going to show.
Did Marcin freeze for you? Yes?
Yeah.
Okay, cool. I will DM him, but meanwhile, we can also answer some questions while we wait.
Oh, I can also continue because I think now it's anyways kind of like
Whereas
time.
Oh, okay, Marcin, you're back. Okay, hello?
Whoa.
Whoa. Yeah. Sorry, you froze, and then Hilmar said, "That's fine. We'll just take over and kick him out." No. Okay. If you go back to sharing your screen, what slide were you on? I think you just mentioned the is it C3M? The what do you call it? Yeah, you were just showing the UI, talking about like the 200 runs per month for Angle.
Okay.
And
Can
then,
you see it again?
Let me bring this back up. Okay, cool.
Yeah, am I back?
Yes, you are back.
All right. So look, it works. Now it's 201 updates this month, and still we have 100% success. So it's good result. It still goes and run. But I wanted to recap that it's a very simple example where Gelato Web3 function just fetches the data from our RedStone data distribution layer and delivers it on chain with a specific interval. But you can also create a more sophisticated conditions upon which the data should be updated. Therefore, we created a repository with integration ARX provider, which delivers arguments upon which data should be updated, and iteration ARX processor, which literally takes these arguments that is specified in provider, checks if conditions are met, and if so, it updates the data feed on chain. So you can imagine some protocols that manage liquidity or do some more sophisticated DeFi strategies that can set these kind of parameters. And up until now, it was mainly deviation threshold of a price feed or an interval, it was updated, which opens up new possibilities within the Web3 ecosystem. Okay, so I'm going to stop here, pass it back to Hilmar, and also share some of the links that I was talking about.
Okay, cool. Should we answer some questions now? Maybe after. Okay, there's one question about RedStone and Gelato together, so we'll leave that for the end. This is a fun one. Maybe you know it. Why do we use the name Oracle?
Honestly, I hate it. Sorry to say it, but Oracle is super generalistic. I mean, in my opinion, layer 2 or rollup, for example, is way more accurate in regards to what is happening on the infrastructure level, whereas Oracle is like basically delivering any kind of information in a truthful manner, right? But in essence, what happens right now when you talk about oracles is delivering price feed of assets, and mainly these are like crypto assets. So I would say Oracle, as we have them right now, is a subsection of what people think of when they hear about the concept of an Oracle, right? So I don't know, maybe Hilmar, you have another perception of that.
What I was gonna say was Oracle's a way better name than Gelato in terms of signifying what it means. But unless you want to say anything to that, I think we can pass it back to you.
I think Gelato is more delicious than an Oracle is. So 1 point for us, I guess. Yeah, I would call it like Oracle. I would, for me, it's data curation and provision, right? So what do oracles do? They curate data. I think this is like the most overlooked thing in oracles, right? It's not about like some data, it's about what data and getting access to that data. I think that's like probably one of the most important things, right? If you say, hey, I will provide the ETH price, but then you're getting it from somewhere which is not reflective of the true market price, then you're doing a bad job as an Oracle provider. So data provisioning, and then of course aggregating that data and then providing it and making it accessible, right, is the other part. And then how this data then gets distributed is like, for example, what you can do with like Web3 functions on blockchains, what Gelato focuses on, right? We just take data and we push it on chain. And so let me actually show you guys how this can be done with RedStone. All right. So
as for Gelato name, I think you still are good because you have so many types of scoops and you have so many types of using Gelato. So I suppose their analogy is there.
Yeah, Emily, I don't know what's going on, Emily. How can you hate the name Gelato? It's
I don't hate
the
the name Gelato.
first time I hear that.
I was just saying Oracle makes more sense to me. But that's fine.
It's all about not making sense, by the way. It's all about that. All right. Anyways, enough about the marketing talk. Let's talk about the code here. So we have a very sort of easy example of an Oracle contract, and this is a very traditional Oracle contract, which basically just stores a price on chain, and this price is like the ETH USDC price. And it's very simple. You will probably not have to worry about that part, but at the end of the day, it's just there's a function called, maybe let me do this, make it a bit larger for you guys. There's this update price function, and we want to automatically call this function every certain like at a time interval, or if there is a certain deviation from the price that has been stored on chain, which means, let's say if ETH USDC trades at, let's say, $1,800, right? If it suddenly trades at 2% more or less on centralized exchanges like Binance or so, then which the RedStone data should reflect, then we want to send a transaction to this smart contract on Linear, for example, that then updates this price. And you might think, hey, there's no inputs here, like, hey, Hilmar, how are we updating the price? This is actually kind of like a funky way how RedStone does it, I guess, to save gas, where the actual price data is not inputted via like the regular arguments like this, right, where you do new price or something. Sorry, I just overwrote the function word, but basically as the input, right, new price, for example, we are not doing like this. We're actually appending this price data on the call data of this transaction by kind of like playing around, and then in this function here, which has like another function, it's somewhere hidden, I don't want to bore you with it, but there we are basically slicing off the excess call data that was sent to this function and then decoding it to then get the actual price that we are pushing on chain. And how are we doing this? Why are we doing all of this? It's because we're doing gas golfing in order to reduce the price of pushing this data on chain. This is actually also how rollups work, right? Rollups are they're just not calling a function, they're just sending a transaction, just sending a transaction to a specific address, and then all the transaction data, it's all just sort of put behind the regular transaction data. So this is the cheapest way of doing it, right? That's why RedStone does it, and that it makes sense. So how do we actually update this? How do we call this function at certain conditions? And this is sort of like how our Web3 functions come in. So we have this contracts folder here, which is our smart contract, our RedStone Oracle, and then we have this Web3 functions folder, right? And this Web3 functions folder has an index and a schema and a user argument file, and we will go into all of them right now. So first of all, we got this index file, and this index file is basically the meat of the Web3 function. And here what we have is we have this Web3 functions on run function, which is kind of like the default function you have. And in that function, there's all the logic we want Gelato nodes to run on our behalf. And we can import some cool libraries in here. For example, we can import a package by RedStone that makes it extremely easy to query RedStone data in our Web3 functions. We also define some sort of API here to update the Oracle, right? So let's open that up. And this is the function, right? First thing you see is there's some user arguments that are being passed to this function, right? Where are these user arguments being defined? Let's go to the user args.json file that you can define also in the Web3 function template. And here you can define, and they're all strings, by the way, you can define what sort of inputs you want. In here, you can define the currency that you would like to track. In this case, we want to track the ETH price, and then the Oracle address of the smart contract where this transaction should be sent to, right? By the way, there's also a schema that you can define. For example, you can say, hey, these two inputs should be both strings. And then you can define like some timeouts, memory usage, and in the future, other things that we will add later on. So bear in mind, the schema is still being sort of updated. So yeah, how does this Web3 function work? So first of all, we get like the user arguments. We get this multi-chain provider. That's a cool one because it gives us read access to all chains, basically. Very cool provider here. And then we say, okay, we want to get the Oracle address. We want to get the currency from the user arguments. We want to instantiate a smart contract, being this Oracle contract that we saw, right? And now the cool thing is we are using the RedStone package to call and query the latest price information, right? And this is kind of like an object that we get returned, which is called this wrapped Oracle object here. And it has a bunch of stuff, right? It has the decimals of the Oracle, right? It has the live price, store price, all these kind of things attached. And it has a certain price deviation as well. And what we can do in here is we can basically go in and have a look at, okay, what is the price deviation from the last update compared to the current one, right? And we can define like a minimum deviation that we want to have, let's say is 0.2. And then we can query, okay, is this deviation smaller or greater than what the new one, what the new price is, right? And if it's smaller, so if there shouldn't be an update, then we just have to return can exact equals false, which means, hey, Gelato, please don't send a transaction. And we can return the message being, hey, no update, price deviation is too small, we don't need to update, right? But in case the deviation is actually greater than the one that we defined, what we then want to do is we want to get the call data. So we want to get the data, which includes the new price that we have to send to this update price function that we saw here, right? And then we just want to return true plus define where we want to send the transaction to the Oracle address and then the data, which includes all the signed Oracle data. And then what Gelato will do in this case, they will send the transaction with the required data. And so how it works, so we got this, let me just delete this. We got this Web3 function defined. What you have to do is you have to go to your command line, and then you just have to run a command, npx web3f deploy, and then basically the path to your Web3 functions. And what this does is basically it takes your code and it publishes it on IPFS, right? And you get returned this IPFS CID, which indicates, hey, this is where this logic lies. And then it returns you this nice link, which you click, and bam, you're on the Gelato interface where you can now set up this task, right? And it all automatically auto-populates this field here, which indicates where the Web3 function is. As a currency, we'll input ETH, right? And as the contract address, let me actually see, I think I had it here somewhere. As the contract address, we want to get this one. And so we put in this in here. And then we can also define secrets. So we can maybe we want to maybe there's some APIs that require API keys, for example, right? So we can actually set secrets here as well. And then we can set it a name, Emily's RedStone Gelato Workshop, and we can hit create task. And this will then, we have to sign a message to sign, hey, we actually want to name it like this, and then we have to send a transaction. And then it will take a moment. And what this will then look like is it will redirect to our task page that we all know and love, which looks like this here. I already created the task before. And then the cool thing is what you get is you get these logs. And these logs basically show what the Web3 function returns on every run. So every run it sort of runs. And then this run, for example, was, hey, Koenigsegg is false. No update is needed. The price deviation is too small, right? So no transaction has been sent. But now if the price deviation was actually larger than the one defined, we would actually send a transaction to update the price. And here you can see, okay, the task is now running and you get access to the same logs. You can actually see the code here as well. You can just like go through the code, check out if there are any issues. You can access storage. You can access the secrets. For that, you need to log in, and you have an overview of all the transactions that have been executed. And yeah, that's kind of like how you can then, this is now your sort of push-based Oracle without you having to run any sort of external servers yourself. It just runs. You can pay for it in USDC that you can deposit here. On testnets, we are sponsoring all that money for you. But on production networks, obviously, you have to do it yourself. And that's it.
Wow. That was very cool. See, this is why I don't need to do my job, because you guys do it better. Okay, few things, I guess. First off, I think you guys do win. There are some comments here. Gelato does sound tasty, and I think specifically Tom was like, gelato's better, so I concede to the audience. The other
Thanks,
piece,
guys.
I guess,
Thanks, guys.
we had a question about, are these solutions blockchain agnostic, blockchain specific? If people want to get started building, obviously you guys are on Linea.
Yeah, I think RedStone is, I think you're supporting all sorts of blockchains, right? I think you're one of the projects that support the widest array of all blockchains. We are definitely striving to do the same. I think we are now live on 14 or 15 different chains, all the big EVM chains that you know and love, and all the new ones coming up as well. If you see that we don't support a chain that you like and love and want us to be available on, just shoot us a message.
Okay, very cool. Are you guys,
So for us,
RedStone's on, oh, sorry, go ahead.
Yeah, so we are present on all EVM layer 1s, layer 2s, and layer Ns, actually, because like the infrastructure was designed in 2021 when we already saw that EVM is going to be probably the future, at least that was our understanding. And we created it that even right now, solutions such as Caldera, that is like a rollup as a service, or other like layer Ns, can use it out of the box. When it comes to non-EVMs, we are on Starknet and Fuel Network and Telegram Open Network. And how we choose these is mainly depending on the Oracle demand. And yeah, I would say mainly that.
Oh, very cool. I did not know that. Okay, so RedStone's on mainnet. Is Gelato on mainnet yet, or
soon TM?
Soon TM. That's fine. It's a process.
It should happen any. I think today actually we're going live, but I have today or tomorrow.
Oh, really? Wow. Okay, cool. Nice. Okay, so there was a question about security somewhere. I need to find it. This one. So it's very long, but probably just more so talking about security in RedStone and Gelato Web3. I am curious kind of how you guys evaluate which feeds to include, what goes into that decision-making process. But whoever wants to answer this, take it away.
Yeah, I suppose there are two components over here. One that I can take over is like how the data is aggregated and in the end delivered, like in the end this available for distribution, maybe call it that way. So we pull data, as I said, from multiple sources. If we want to, for example, bring a new data feed, we always require at least 3 independent sources with each having at least $1 million of liquidity. So GAD, it's not that easily manipulated. Usually it's even higher, because in practice, for example, right now we've seen the curve situation on the market. It's very easy for liquidity to go away, and then Oracle can be fairly easily, let's call it, manipulated. And we have to monitor all of these kind of events and then react accordingly. For example, if there are 5 sources and it turns out there is an event that one of the sources lost at, let's say, 80% of its liquidity, we have automated like algorithms that pull out that of the data source, so that it's not that easy manipulated. Because if we hadn't done that, then someone could deploy some cash to a pool and then manipulate the price and take advantage of such a situation. And when it comes to decentralization, as I was showing you data provider nodes, anyone can join the data provision side. So let's say the supply side of data, as long as you stake RedStone tokens. And then the stake that you have is subject to slashing in case you deliver either bad data or you stop delivering the data as you promised to the users. So it's like an incentivization mechanism to play as a good player in the whole, let's say, game.
Cool. Yeah, I think maybe from my side, from the Gelato side. So yeah, as a reference, Gelato has been operating live, being live now for over 4 years. We have a bunch of projects in the space, from MakerDAO to Connex, PancakeSwap, and yeah, many others. Rely on our infrastructure day in, day out. And of course, we try to strive for being as reliable and robust as possible. For that, what we launched in Q2 of this year was actually our network decentralization with staking. And so we now have over 5 operators in this space, which are basically BWell Labs, P2P, staking facilities, and 2 others that I don't remember right now, but they are running Gelato nodes. So if one of them is down, we have a peer-to-peer network using lit peer-to-peer, which then gossips the tasks that should be run between them. So if one of them doesn't respond in like a certain period of time, the others automatically take over and run it and execute it on your behalf. So we have a redundancy there. Obviously, every node sort of is as reliable as it gets, and they're professional teams actually doing it. They're running like Lido nodes, for example, also Solana nodes, right? And so these are professional teams. They have a lot at stake as well. They have to acquire gel and stake it. And the more they actually run and execute, the more revenue in the system they earn. So they're actually incentivized to have uptime. And if they don't have uptime, they basically don't make any money. So there's a strong incentive to be up and running, strong fallover. So yeah, this is how we ensure that the system is always up, running, and executing.
Okay, cool. I think that is everything. There's a few like, great job, Hilmar, go RedStone guy. So that's awesome. I don't have anything more unless you guys wanted to say anything else. I will be asking for, I guess, do you have like the repo link and all of that information, like docs, etc., that you can share either now or I can share it with the people later?
Yeah. Definitely, I have it. Let me just grab it for you.
Thank you.
So I just shared the 2 links in the comments on YouTube. So if people are interested, they can pick it over there directly.
Cool. You can also paste each of these little letters in specifically. But that's fine. I will also be sharing this after the stream, so you guys don't have to look at all of this. Let me write this down so I have it. But otherwise, if you guys have nothing else you want to say, we can close off here. This is super fun. You open your mouth.
Thanks a lot. I suppose from my end, I hope to see all of the Linea builders on ETH Warsaw that is happening in a month in Warsaw, Poland. And then later on other conferences such as like Dev Connect in Istanbul. I suppose this is going to be a big one. A little bit told me that some ice creams are going to be available in Istanbul for developers as well. So you can look out for delicious gelato there.
Yes, indeed. We will be there. We will also be in Asia if you're in Asia, Korean Blockchain Week, Singapore. We will be there. So definitely hit us up. Come to our Discord if you have any questions. And yeah, let's build something cool together with RedStone and Gelato. And yeah, we are definitely, both teams are very eager to help you realize your product. So hit us up.
Your Web3 dreams. Okay, cool. Yes, this does remind me, Linea, we currently still have our virtual hackathon running, I think, until the end of August. I believe people from the hackathon are watching this, so if you're working on it, think about off-chain data, think about Gelato. Otherwise, September 22nd, I think, is ETH Global New York, and then we also have the hackathon in Istanbul as well. So yeah. Again, thank you guys so much for coming. Thank you again for doing my job for me. This was super easy. I love getting to sit back and listen. Okay, cool. So I'm going to end the stream now. And
bye-bye.